going to learn about springs. Springs are simply objects that can be used to store mechanical or potential energy. Springs come in all sorts of shapes and sizes and can be used for a variety of reasons. Many springs will stretch and they'll also compress. Some springs are much easier to stretch or compress than others. Everything will stay exactly how it is unless there is a force acting upon it. Just like with springs here. When it's just like this, it is in its equilibrium position and there is no net force acting on it. So if I take a force and apply it to the spring will stretch until there's a new equilibrium position. At this point, all the forces are canceled out, so the force I'm applying this way is being canceled out by the spring. As you also might know, every spring is slightly different. They may have as what is known by physicists as a different spring constant. This means that some springs are much easier to stretch or compress than others. Such as given here, all of these springs have slightly different spring constants. And as you can see, they all have about 4 newtons of force pulling down on them with these weights. Hooke's law states that force equals negative k times x, where k is the spring constant and x is the distance that the spring is stretched. All of these are originally the same length, and they all have the same amount of force acting on them, but the x is different because of their different spring constants. So, as you know, the force equals the negative spring constant times the distance which the spring is stretched. As I will now demonstrate, I will stretch these springs the same distance, even though they have different spring constants, so different forces will act upon them. They are both starting with a distance of 27 centimeters. As I stretch them out, you can clearly see that the spring constant for the white spring is much greater than the spring constant for the blue spring. So it requires a lot more force to stretch it the same distance. So now we can use our previous knowledge to calculate the spring constants of these two springs. Here I have 1 kilogram masses, which will provide about 9.8 newtons of force onto these springs. Each of these springs is currently 27 centimeters long, but as you can see, when I apply a mass, they stretch out. We can now go over and do some simple calculations and find out what their spring constants are. Since F equals negative kx, we can easily find the spring constants. So we set up our equation as negative 9.8 equals the spring constant of the blue spring times the change in distance. So in this one, the spring stretched from 0.27 meters to 0.59 meters, while with the white spring, it stretched from 0.27 meters to 0.52 meters. So we can easily solve this equation out to find out what our spring constants are. So now we're going to solve these equations out. The negative 9.8 Newton force stretched the blue spring a total of 32 centimeters. And now since we want to get the k by itself, we divide. So negative 9.8 over 0.32 equals 30.62 Newton meters. And now for the white one, we do negative 9.8 over the distance stretched, which is 0.25 meters. And that equals about 39.2 Newton meters. And that is how you calculate the spring constant for any spring. Now that you guys have the necessary tools to figure almost anything about springs with using the spring constant, I have a problem for you. If I know the spring constant of this spring is about 25, and I have a mass of 0.6 kilograms, How far do you think I will stretch this spring? The spring is already 27 centimeters long, and so we'll find out how far it goes. Are you ready? As you can see, and as you probably could have calculated, the spring stretched to about 50 centimeters, or it stretched about 23 more centimeters than it was in its original equilibrium position.